Hi guys, my name is Peter and welcome to a new video. So in this video, I'm going to show you how you can create virtual private cloud or VPC using Terraform. So if you don't know what a VPC is, please do watch this particular video of mine. I have explained VPC in a detailed manner, and also you will get a hands-on experience on how you can create VPC. So if you know already about VPC, now it is time for us to create one using Terraform. So as you can see on the screen, this is the architecture that we are going to create in this particular video. So whenever we are trying to create anything using Terraform, especially something like VPC, it is suggested, or it is a best practice to kind of visualize what we are creating, because if not, otherwise there can be situations in which we can miss out on certain services and later run into error. Instead, if you visualize everything before, then you can have a clear path or idea regarding what you want to create, and then things will be much more easier. So here you can see that we are having a region. For example, we have got the Mumbai region. Then this is the region in which we are gonna create the VPC. So once we have decided the region, then we are going to create the VPC. So you can see that our VPC is extending over two different availability zones, that is US-East-1A and US-East-1B. Don't mind the Mumbai region and the availability zone region name is different. This is just for an example. So in each availability zone, we are having a public subnet and a private subnet, and that's it. Now these subnets are connected to a route table, then to an internet gateway. So now you have got an idea regarding what all things that we need to create. That is, we need to have a VPC, subnets, route table, and an internet gateway. So these are all the things that we need to create in order to basically build our VPC. So now it is time for us to get on to the coding part. So here I have already opened up my VS Code right over here. Let me zoom in a bit, and also let's get into full screen. And here I have got two different files. These are nothing but these are the variables for Terraform to access my AWS account. That is the access key and the secret key. That's it. Now let us create our main file. That is our main.tf. Alright. And yeah, now let's get started. So the first thing that we need is the provider. So I'm going to search for AWS provider Terraform. Alright, let's go to the first link and let's copy it right from here. And surprisingly, we also have got the code for VPC. So let's copy everything from here and paste it right over here. So we are having an indentation issue, so let me indent it properly. Alright, now that looks beautiful. Let me do the same for all these things and let's save it. Alright. So we have defined the provider, which means that we are telling Terraform that make use of HashiCorp's AWS version, and the version should be anything above 5.0. And here we need to configure the AWS provider. So here we have got provider AWS, we have provided the region, which is going to be US-East-1, and also we need to specify the access key and the secret key. So the access key and the secret key need to be specified right over here. So it is going to be var.access key, and this is going to be var.secret key. Alright, now we have configured the AWS provider as well, and now it is time for us to create the VPC. So the resource that we are going to create is a VPC, and the name is gonna be main_VPC. Alright, and now we need to provide the CIDR block. So if you don't know about CIDR blocks, again I suggest you guys to watch my VPC video. In this video I'm gonna not spend any time discussing about CIDR block and other stuff. I have already created my CIDR block addresses right over here, that is 18.0.0.0, and the mask bit is 20, and I have already divided it, and I have explained all these things in my VPC tutorial. You can watch that. So here I'm going to copy the main network address from here, and let us paste that right over here, and the mask bit is going to be /20. Alright, now we have created the VPC, and which means that we are done with this particular part. And now it is time for us to create subnets. We need to create 4 subnets, 2 in one availability zone and another 2 in another availability zone. So let's get started with that. So for that, I'm going to search for AWS subnet Terraform, and let us go for the first link. Yes, this is what we need, and I can see the resource is going to be subnet. We have got the VPC ID and the cider block, so I'm going to copy it from here and let's paste it. So let's give it a tab, and I'm going to remove the tags from here. Alright, so this is going to be our public subnet. So I'm going to name it as public underscore subnet underscore 1. Alright, so here let's give a comment as US east 1A. So this subnet that we are going to create, that is a public, and the private is going to reside under the US east 1A subnet, which is this one right over here. Alright, so we have provided the VPC ID, which is going to be VPC AWS underscore VPC, and the name of the VPC is main underscore VPC. So let us replace that. And yeah, so the VPC ID is nothing but when Terraform is going to execute these code, and when AWS is going to provision the resource, it is going to automatically create an ID, and that ID is what is going to be assigned right over here. And now we need to specify the cider block. So let us go to our subnet calculator, and I'm going to copy the first one right over here, and let us paste it right over here. Alright, so this is going to be our cider block for our public subnet 1. And now if I go to our AWS underscore subnet, and if I scroll down, you can see the different argument references, and availability zone is one of them. So I'm going to copy that from here, and I'm going to paste it right over here. So the availability zone that we want this to be in is US east 1A. Alright, so this particular subnet is going to be placed inside the US east 1A subnet. And yeah, another important thing that we need to specify here is that since this is going to be a public subnet, any resource that we are going to deploy into this particular subnet should be public as well, right? So there is an important argument, that is, if I scroll down, you can see that map public IP on launch. Specify true to indicate that instances launched into the subnet should be assigned a public IP address. Default is false. So this is an important argument, and I'm going to copy it, and I'm going to paste it right over here. So which means that if I set this particular argument as true, and if I deploy any resources, for example an EC2 instance inside this particular subnet, then AWS is going to automatically assign an IP address, a public IP address, to that particular instance or resource, which means that that resource can be publicly accessible, it can be directly connected to the internet gateway, and thus it can have internet access. So that is the main purpose of setting this particular argument as true. And since this is a public subnet, we need this particular parameters to be set to true. And that is it. So these are the different parameters that we need to set for a public subnet, that is public subnet 1 under the availability zone US east 1A. Now if you go to a diagram, we have created this particular public subnet inside this particular region, and now let's do the same for this particular private subnet. So I'm going to simply copy the code down, and the things that I'm going to change is that we're going to change it to private subnet 1, and the VPC ID is going to be the same. The cider block is going to change. So let us go to our subnet calculator, and I'm going to copy the second value or address from here, and I'm going to paste it right over here. Alright, so the availability zone is going to be the same one, and the map public IP on launch is going to be set to false. Alright, so now we have successfully created the availability zone 1A, and we have created two subnets, public and private. And now let's do the exact same for our US east 1B availability zone. So I'm going to copy this thing from here. So let us change the comment to 1b and the public subnet 2. The VPC ID is going to be the same, but the CIDR block is going to be different. So I'm going to copy the third one from here. Let us paste it right over here. The availability zone is going to be 1b. The map public IP on launch is going to be set to true. Alright, so let's go to the private subnet. Let us change that to private subnet 2. VPC ID is going to be the same. The CIDR block is going to be this one. Let's paste it right over here. The region, the availability zone is going to be 1b, and yeah, the map public IP on launch is going to be set to false, which means that we are done with most of the part of creating our VPC, which is we are done with creating the VPC, setting up two availability zones along with public subnet and private subnet in each of these availability zones. Yeah, and now it is time for us to create our internet gateway. Now when it comes to the route table, the way it works is that, so when AWS is gonna create the VPC, which is right over here, when AWS is going to create a VPC, by default AWS is also going to create the route table, and it is going to automatically match what all subnets are public to that particular route table and what all are private to the route table. So a default route table is going to be automatically created by VPC, and the matching is going to also happen automatically. So we need not explicitly create a route table, but in certain cases if we want to map things differently, then in that particular scenario we need to create a separate route table and configure things in a different way. But for this particular tutorial, I think that we can go with the default route table and we need not create a separate one. And now it is time for us to create the internet gateway. So again, let us search for AWS IGW Terraform, and let us open up the first link, and this is what we need. So I'm going to copy it from here. Let us scroll down and I'm going to paste it right over here. Let us give it an indentation, and I'm going to remove the tags from here. Also, let me give a comment IGW. Alright, so here we need to specify the VPC. So it is main underscore VPC, and that is it. Now this particular internet gateway is automatically going to get connected with our VPC. Alright, so let us basically run the code that we have written till now, and let us see if we have got any error. So the first thing that I'm going to do is that I'm going to initialize Terraform. So I'm going to enter Terraform init, and let us wait for Terraform to initialize into this particular directory. Alright, Terraform has been successfully initialized, and now let us run Terraform plan and see if we have got any issues. Surprisingly, we don't have any. So before executing this particular command, let us go to our AWS console and see the current state of my AWS account. So here we have got my AWS account, and let us go to the VPC section first of all. Let us go to your VPCs, and here you can see that we are having a single VPC, and if I scroll to the right you can see that this is the default VPC. And just like that, if I open up subnets right over here, you can see that there are a couple of subnets, but all of these are default subnets. All of these are default subnets, which is automatically by default created by AWS. And same is the case with route table. We are having a single route table, and this is basically the default route table right over here. And if we go to internet gateways right over here, you can see that we are having a single one, which is the default internet gateway. So now let us basically run our command and see if things are going to work out. So let us type in Terraform apply, and let us run the command. Let us type in S to approve this particular action, and let us wait for Terraform to communicate with AWS via API and create our resources. So AWS VPC main is being created, internet gateway, public subnets, all these things are created, and you can see that an ID is being provided to each of these different services. And just like that, apply complete, resources 6 added, And now if we go to our VPC and if I refresh it, you can see that we are having a new VPC right over here. And if I move to the right, you can see that this is not the default VPC, and we can see all the different information. So if I copy the VPC ID from here, and if I go to the subnet section, and if I refresh it, you can see that we are having a lot of them, and I want to filter it via the VPC ID. And as you can see, we have got 4 of them. And if I move to the right side, you can see that these are not the default one. You can see that they are deployed in US-1A, US-E-1B, 1B, 1A. This means that we are having a public, a private, again a public and a private. You can identify that by moving to the right. You can see that auto assign public IP is enabled for these two, which means that these two are public subnets, and these should be in different zones. Yeah, they are in 1A and 1B and 1A, and the other two which have got auto assign public IP turned off are private subnets in 2 different availability zones. Alright, so you can see the IPv4 CIDR addresses, and route table is also going to be created, and this is going to be a route table automatically created by AWS. You can see that this one is right over here, and you can see the VPC also, that is which VPC is this route table associated with. And the same is going to be the case with the internet gateway as well. We will be having a new internet gateway. So if at any case, if you don't see these things right over here, make sure that you are in the right region by navigating to the right region, or the region that you have specified right here in your Terraform code. Only then you can see all these resources. So which means that our code was successful. We were able to create all these resources. And now let's see if we could basically create or deploy an EC2 instance to one of our public subnets. So let us close this and let us see how we can create an EC2 instance. So EC2 instance Terraform. Alright. Let us scroll down, and I'm going to copy this particular code from here, and let us paste it right over here. Let us indent it. Also, I'm going to remove the tags. Let's also align this perfectly fine. Alright. So here we are creating an AWS instance resource. The name can be test-server. Alright. Now we need to provide the AMI. So for that, let us open up EC2 instance right over here, launch an instance, and let us simply provide an AMI ID of a simple Amazon Linux machine. Let us scroll down. So Amazon Linux, and I'm going to copy the AMI ID from here, and let us paste it right over here in double quotes, and the instance type is going to be T2 micro. Now we need to decide on which subnet we want this particular instance to be created. I think that we can create it in this particular subnet right over here. That is the public subnet under US-E-1A. So to find out that, let us go to our AWS instance section, and if I scroll down under the argument section, I think that we can find the subnet argument. Let us search for subnet. Alright, here you can see that we can provide subnet ID. So I'm going to copy it from here and paste it right over here. Let us indent it as well so that things look pretty beautiful. So we need to provide our subnet details. So as we discussed earlier, we are going to deploy it in the US-E-1A availability zone inside the public subnet 1. So let us copy the name from here, and let us replace example with our public subnet 1. That is the name of our public subnet under US-E-1A. Let's save it, and let us see if this is going to work. So let us open up our terminal, and I'm going to type in Terraform plan to see if we have made any mistakes. So you can see that now Terraform is confirming with AWS to see if our VPC route table subnets all exist or not. Now we don't find any mistakes, so let us run Terraform apply. Again, you can see that the verification is happening whether the VPC and all these things exist or not. And let us approve the action by typing in S. And now let us wait for our instance to be created. So our AWS instance test server is being created, or it is being created, and this can take a couple of seconds. Alright, the apply has been completed. So if I go to our instances right over here, instances, we might be able to see our instance. Yeah, so don't worry about this one. This is one that I actually trialed or kind of tested if things are going to work. So this is the instance which is currently running. I can filter it by instance state running. So you can see that this is the single one, and the availability zone is US-East-1A. And if we can go to more details, you can see that we are having an auto-assigned IP address. This is the public IP address, and the instance IPC2 micro. The region is US-East-1A, and if I scroll down, you can see the VPC ID. This is the VPC that we have created, and this is a subnet that we have specified for this particular instance to be deployed on. And this was a simple test. This is not really how we can create an EC2 instance. We need to specify the SSH, the security group, and all these things to be specified before you create an EC2 instance. And in this video, I just want to show you guys how we can kind of create a VPC, and just to test it out, I just want to put an EC2 instance in a specific subnet. That's it. And guys, this is not really an efficient way of creating a VPC, because you can see that we are kind of writing these things multiple times, and this is not really scalable. There are different ways in which you can write it, like you can create a separate variable folder for VPC, a separate variable folder for public subnets. Then you can specify these different availability zones in the form of array, and then when it comes to the main file, you can iterate through the array and automatically assign it. There are much more efficient ways in which you can write these code. But the aim of this particular video was to show you guys how we can kind of create a VPC, how the things work, and that's it. And maybe in a later video, I'll show you guys how we can create a more efficient and scalable code to create a VPC. So if you want a video like that, please do mention that in the comment section. So now let us wind up the video by clearing or deleting all these resources. First of all, I'm going to terminate our instance. All right. And while that is being terminated, let us go to our VS Code and type in Terraform destroy. And this is going to completely wipe out all the resources or services that we have created till now. Let us type in S to approve the action and wait for all these resources to be completely destroyed. And just like that, the destroy is complete. Resources 7 destroyed. So let us verify. So let's go to VPC, and if I refresh it, we should be able to see only one. Yeah. So these are the subnets. So if I remove the filter and if I refresh it, then I should be able to see only 8 of them. Yeah. Route table should be gone. And just like that, the internet gateway also should be gone. And our instance is terminated as well. So that's it, guys. So this was a simple video that showcased how we can create a VPC using Terraform, and I really hope that you guys got a basic idea regarding how it can be done. And if you have got any doubts, you can mention that in the comment section, and I'll be more than happy to help. So once again, thanks a lot for watching, and I'll see you guys in the next video.